Hello everybody, in this video we are going to be discussing a way to find the derivative using the quotient rule. So let's say I have a function p of x and it can be expressed as a quotient of two expressions. Let's say f of x divided by g of x. So the derivative of p of x is p prime of x, and using the quotient rule we can take g of x multiplied by the derivative of the numerator, which is f prime of x, subtracted by f of x times g prime of x, and we can actually switch the order of these two terms of the multiplication. So we can actually rewrite this as f prime of x times g of x minus g prime of x times f of x. And it doesn't matter which order you have these two terms in as long as you multiply them, but one thing you cannot do is you cannot take this quotient and subtract this quotient. You must take this quotient and subtract this one. So after you subtract these two quotients, you divide it by g of x squared. Now, this is the quotient rule, which seems kind of daunting, but here are a couple examples which should clear up your doubts. So let's say I have p of x equal to x squared plus 3x divided by x plus 4. So we have p prime of x, and we can find this value by using the quotient rule again. So we have the denominator x plus 4 multiplied by the derivative of the numerator, and the derivative of this numerator is 2x plus 3 subtracted by the numerator multiplied by the derivative of the denominator, which is 1, divided by the denominator squared. So you may be thinking, why don't I just expand this denominator? But if you expand this, it makes the expression more complicated when we're trying to simplify and reduce. So rather, we'll focus on the numerator. So we can multiply like terms together. So we have 2x squared plus 3x plus 8x plus 12 minus x squared minus 3x divided by x plus 4 squared. And when you collect like terms, you'll have 2x squared minus x squared plus 3x minus 3x plus 8x plus 12 divided by x plus 4 squared. And then when you simplify, you have x squared plus 8x plus 12 divided by x plus 4 squared. So you may be thinking to yourself, this is done right, but it's actually not done, because you can factor the numerator, so you'll have x plus 2 times x plus 6 divided by x plus 4 squared. You can't reduce this anymore, so this is the value of p prime of x, which we found using quotient rule. Now here is a second example. Let's say we have p of x equal to sine x divided by x squared. This looks complicated, but it's the same thing as last time. So we have p prime of x equal to x squared times the derivative of the numerator, which is cos x, minus the numerator sine x times the derivative of the denominator, which is 2x, divided by the denominator squared. So we have x to the power of 4. So looking at the top, so the numerator, we have a common factor x, so we can factor that out. So we have x cos x minus 2 sine x, and then all of that divided by x to the power of 4. We have x and x4, so we simplify that. We have x cubed on the bottom, and then we're left with x cos x minus 2 sine x divided by x cubed. We can't simplify this anymore, so this is the value of p prime of x using the quotient rule. And there's actually multiple ways to find p prime of x using product rule and chain rule, which I will make videos on later on. Thank you for watching.